All right, in this video, I need to go over example 8 that I didn't get a chance to finish in class. Here we're talking about the 7-step method of solving graphing a rational function, and we use that 7-step procedure for this function, f of x equal to 4x squared divided by x squared minus 1. All right, so the first step, if you recall, is finding symmetry to determine whether we have y-axis symmetry or origin symmetry, or it could be no symmetry. So step number 1 is symmetry. And we use f of negative x. F of negative x. So we just substitute every x in that function with negative x. So I have 4 times negative x, and that's squared, divided by negative x, and then that's squared, minus 1. Anytime you square a negative, it's going to be positive, by the way. So negative x and u squared will be positive x squared. So I have 4x squared in the numerator. Same holds true in the denominator. Square negative is going to be positive. So it'll be positive x squared minus 1. Now compare that function, f of negative x, with f of x. I get the exact same thing. So that tells me that the graph of this function will be symmetric with respect to the y-axis. So it'll be y-axis symmetry. All right, so that's step number 1. Now step number 2 is the y-intercept, finding the y-intercept. To find the y-intercept, we always let x equal 0. So we're going to evaluate this function at x equals 0. So we just substitute every x in that function with 0. So I have 4 times 0 squared divided by 0 squared minus 1. Well, if I square 0, that's going to be 0 times this 4 in front would be 0, divided by 0 squared is 0 minus 1 would be negative 1. So 0 divided by negative 1 is 0. So my y-intercept will be the ordered pair 0, 0. It's going to be at the origin. And then step number 3 is finding the x-intercept. When you find the x-intercept, you take the numerator of your f of x function, set that equal to 0. So I'm going to set 4x squared, which is my numerator, to be equal to 0. And then solve for x. So if I divide by 4, that means x squared is equal to 0. And then take the square root on both sides to get x by itself, so x would be equal to 0. Okay? Notice I didn't use plus or minus because 0 is neither positive nor negative. So my x-intercept is the ordered pair 0, 0 as well. Now step number 4 is finding the vertical asymptote. Now there may be more than one vertical asymptote. So in this case, I'm going to take my denominator, and by the way, since there are no common factors to divide out, I can go ahead and take that x squared minus 1, which is the denominator, set that equal to 0, and solve for x. Well, let's do this. Get x squared by itself by adding 1 on both sides. So x squared is equal to positive 1. And if I take the square root on both sides and include that plus or minus symbol, that means x is equal to plus or minus 1. So that means I have 2 vertical asymptotes in this case. One would be x is equal to 1, and the other one would be x equal negative 1. So those are my 2 vertical asymptotes here. Now, step number 5 is finding the horizontal asymptotes. Well, horizontal asymptote. That's why I use that procedure of identifying the n and the m. In this case here, your n is going to be the highest exponent in the numerator. Your m is the highest exponent in the denominator. So in this case here, the n is the highest exponent in that numerator, which is in this case 2. The m is the highest exponent in the denominator. In that case, it's also 2. So when I compare n and m, we can see that n does equal to m. So to find that horizontal asymptote, we have to use y is equal to a sub n divided by b sub m. Okay, so let's refer back to that rule here. If n is equal to m, then the line y equal a sub n divided by b sub m, those are your leading coefficients in the numerator and the denominator respectively. That would be the horizontal asymptote. So in this case here, a sub n is the coefficient of the variable to the highest power. If the highest power in the numerator is 2, then its leading coefficient must be 4. Divided by b sub m, coefficient of the variable to the highest power in the denominator. If that highest exponent is a 2, then that means that coefficient has to be that understood 1. So now you have 4 over 1, which is 4. So the equation, y equals 4, is your horizontal asymptote. All right. Step number 6 will be the table and the graph. So I'm going to put the table over here for my x and f of x values that I'll need. And that's going to help me do number 7, which is the graph. Okay, so let's graph what we already have. I have a y-intercept and an x-intercept, both 0, 0. That's the origin. I have two vertical asymptotes. One is at x equal 1, and the other one is at x equal negative 1. So here's x is equal to 1. Is vertical asymptote. And the other vertical asymptote would be at x equal negative 1. And my horizontal asymptote is the line, horizontal line, y equal 4. Oops, correction. Y equal 4 is up here. Okay. All right, disregard this line up here. Disregard all of this. Because that's nothing, just disregard that. Because this is the horizontal asymptote right here, going through the y-axis at 4. All right, let's pick values to the left and to the right of each vertical asymptote and x-intercept. My first vertical asymptote is at x equal negative 1. I'm going to use values like negative 4, negative 3, and negative 2, each for x. Now notice in between here, because you got negative 1 here and positive 1 here. What I'm going to do here is use 1/2, negative 1/2, and positive 1/2 for x. Because I need to know what the graph is going to look like in between those two vertical asymptotes. Now my other vertical asymptote, of course, is x equals 1. Let's use x equals 2, 3, and 4. All right, so here's what I'm going to do here. Use my graphing calculator. And I'm going to go to y equal 2, and I'm going to clear this equation out. The numerator is 4x squared. I'm going to put that in parentheses. So I'm going to use the left parentheses, press the 4, press xt, correction, xt theta n for the x. That's this button right here. And then it's squared, so I use x squared to square it. Close parentheses. And then that's going to be divided by, the denominator will be in parentheses as well, so left parentheses, x c theta n for the x, and then press the x squared button to square it, minus 1. Close parentheses. Now, because I got negative 1/2 and positive 1/2, I'm going to need to know what those values are. And the way I can do that would be this. I'm going to do second and table set. Okay. Now, under this part right here where it says the change in table, where it says delta TBL, I'm going to go down here and change that 1 to 0.5. Because my independent variables would be in increments of 1/2. Okay. And then go to second table. Now I'm going to use my up arrow key to go up to -4. You can see it's in increments of 1/2 here. But I'm going to use the ones that I want to use, that I need. Like for -4 to one decimal place, that would be approximately 4.3. Then for -3, it'll be 4.5. Then for -2, that'd be approximately 5.3. Now for -1/2, that's like -0.5, which is this right here. That value there is approximately a -1.3. And then for 1/2, or 0.5, that's going to be -1.3 as well. So pretty much you can see that the graph of this function is going to be symmetric with respect to the y-axis, because at -1/2 and positive 1/2 have the same value for f of x. And you'll see that for the others, like for x equals 2, here 5.3. The same f of x value when x is -2. And then for x equals 3, 4.5. And finally for 4 would be 4.3. All right, so now let's see what this graph is going to look like here. So for -4 and 4.3, here's -4 and then 4, and then 3/10 of the way will be about right here. And then for -3, 4.5, to the left 3 and up 4, halfway between 4 and 5. Then -2, 5.3, to the left 2 and up 5, and about a third of the way. So here's what one part of the graph will look like. It's going to be approaching this first vertical asymptote of x equal -1, but will never cross it. This end will be approaching the horizontal asymptote. It'll never cross it. Now, for what's going on in between these two vertical asymptotes of x equal -1 and x equal +1, the reason why I chose -1/2 and -1/3 is this. Go to the left halfway between that, and then -1 and a third of the way. That's going to be, that point would be there. 1/2, -1.3, same thing. What's going on in between is this. This end on the left of 0 will be coming down to the first, approaching the first vertical asymptote, and this end to the right of 0 will be coming down, approaching the second vertical asymptote, like this. And then for those last 3 points, you can see here what's going on. At 2 and 5.3, about right here. 3, 4.5, halfway between 4 and 5, and then 4 and 4.3 will be about right here. This will be the mirror image of the one that's on the left, approaching the the vertical asymptote at x equal 1. It approaches the horizontal asymptote coming this way of y equal 4. All right, so this is what the graph of f of x equal to 4x squared divided by x squared minus 1 looks like. And hopefully this will assist you with some of the homework that's in section 3.5. And you can always check by using the graph. Doing graph here, you'll see what that looks like. Because see, that part right there is this part here. Okay, so that's all I need to cover in this video. So reach out to me if you have any questions about anything that has been discussed in this video or any of the homework that's in section 3.5 dealing with rational functions and their graphs.